Welcome to part 3, and today we're changing the frequency of the inverter board. The inverter had this capacitor here. It's a 1UF, and we've taken that and we've moved it to the input. I was showing you that last time. I used a Mylar capacitor, but you'll find many ceramics of this style too. I prefer not to use them because the capacitance is not temperature stable, but capacitors will be marked with 0.1 or 104. So you can see the capacitor right here, pulls out, and we replace it. Now another thing is we're removing this resistor here, which is on the gate of this FET. We're not using this FET, but we don't want to destroy it, so we want to have this protected. But I want that 2K resistor, so you don't have to go out and buy parts. And right here you can see there's the gate, and I've done a little shorting lead from a resistor right across there. And what I've done with that resistor is I've placed it right here. We had one before, and now we have two of them in parallel, so that's now 1K. As you can see it right here. Now we had another 1K which came from pin 1 to ground, which made that 2.5 volts. We really don't want to have 2.5 volts there. It'll be much more accurate if we use 5 volts, and so we're running 5 volts right over to pin 1. You could connect these directly together if you wanted, but I have a reason for having the 2K resistors in parallel, which makes 1K. I'll explain that later. But the other thing is on the input we have this 2K. We had a 2K resistor going right to ground, so that made it a 2K input. That's kind of really low. So what I did was, there's two resistors right next to each other, and I pulled them up one leg. I pulled up this one from ground, and this one which connected over here. And I've put them in series. And you can see that right here. One really useful thing is I take a resistor wire or something like that, put a little hook on it, and so when you're trying to pull up a resistor, you get it under one leg, and you're heating it, and you can, when it solder melts, you can pull it right up easily. You're not going to get your fingers in here and pull on these. So you need to make a little tool, find a nice one, put some heat shrink tubing over it, and keep it in your toolbox. So these two resistors are in series. So now we have, let me just draw this. That's our pot input. And so because we changed this from 2.5 to 5, the input also doubled in voltage. So actually the pot didn't change. It's just we have less current going through, and that works out better. It gives a better timing for this 1 microfarad capacitor. So as you can see, this would be the capacitor that you pull out of the timing circuit, so you haven't had to buy a part there. You got two resistors in parallel here. That makes a 1K. Didn't have to buy anything. That was from pulling out this one resistor over here, and you have to put a little shorting bar in. And that's it for today. I'll explain why we did some of these things later. But as you can see, we're up to 510 hertz with a water heating element connected to this forms an RC time constant, and we're going to talk about the capacitor bank later. But since this is going to be a low voltage board and you probably won't use it over 50 volts, we have to have a lot more capacitors because we're pulling more current, lower voltage. This is why I like doing high voltage. And we're upping the frequency so the capacitors don't have to store energy for as long.